देखना पड़ेगा विजिट किया नहीं कोई बात नहीं देख लेंगे क्लास में
Okay, so good morning to all, and today on the second day we are going to talk about quality control aspects of embankment dams. So yesterday we learned about the soil as a material. We learned how we are going to use and what are the various tests which we perform to understand the characteristics of soil, and we also try to understand that how these characteristics of the soils which we are getting as a construction material are going to classify the soil into the usable types, the non-usable types, the soils which require more attention, the soils which we should be avoiding, and we also try to understand that how we can even use a new material called geosynthetics, which can be used at places wherein our usual construction materials are not available to our rescue, or where they are not performing to the extent which we are trying to think of. So today we are going to concentrate on quality control aspects for embankment dams, and a brief introduction of embankment dams. What is an embankment dam? An embankment dam is a dam which is basic or majorly being constructed using soil as a construction material. Of the different types of dams, embankment dams are some of the major types of dams because they are relatively easy to construct. That is why embankment dams are major number in quantities. And secondly, we'll also try to understand today in this lecture, uh, do we really require a quality control? And if yes, why should we require? And secondly, how do we assure that the quality control is up to the mark? And thirdly, what all parameters we need to look into when we work as a member of the quality control team. This is important both for the people who are going to work in the quality control team and also for the people who are going to be on the other side. By the other side, I mean that usually we are having the construction wing and the quality control wing. And in many of the projects, the construction wing usually feels that the quality control people are posing a hindrance to my work. They always feel, okay, now the quality control people are coming, they will stop the work, and so the work progress will be stopped. And end of the day, the speed or the timeline which I have set for completion of the project is going to be hindered. But actually, that is not the case. Why that is not the case? Because it is because of the collective effort of both the construction wing and the quality control wing that final output of the structure is going to be good. And that is what we basically are trying to aim at. So, moving forward, if we try to understand what is a large dam, we start with it. Okay, we come on to the embankment dam, then let us try to understand what is a large dam. So, ICOLD, the International Commission of Large Dams, ICOLD, it's an agglomeration of people from around the world, and they've defined that a dam with a height of 15 meters or greater from the lowest foundation to the crest. So any dam which is having a height more than 15 meters from the lowest foundation up to the crest will be termed as a large dam, or a dam between 5 to 15 meters of height, but it is impounding more than 3 million cubic meters of water. Now why? Why are we saying that a large dam is also a dam which is maybe though lesser in height than 15 meters but is impounding more water? Because the dam which we are constructing is used to store that water. And in case there is a failure of a dam, then this amount of water which is going to be released because of the failure of the dam is going to create a lot of catastrophe in the downstream side. So that is why we say, okay, even a dam which is having a height varying from 5 meters to 15 meters, but the reservoir which it is going to impound is having a capacity of more than 3 million cubic meters of water, will be termed as a large dam. And so what happens if suppose, okay, we term a dam as a large dam, so what is the thing to worry about? The major issue is that in case we are going to categorize a dam as a large dam, then that particular structure is going to have some special attention, and certain rules and regulations are going to be used during its construction and even post construction. Means now, like we are having the Dam Safety Act, so all the structures which come under the category of large dam are to be seen under the Dam Safety Act. And what is the Dam Safety Act? The Dam Safety Act is holistically trying to see that your structure is performing to its maximum. It is not having any zones of weaknesses, or it is not having certain regions which need repair or rehabilitation or maintenance. So that is, so holistically the Dam Safety Act is looking at these structures. So we categorize a structure as a large dam, and so it comes under the ambit of the Dam Safety Act, and ultimately more and more people are going to be looking at it, and it requires the attention which it requires, it is getting there, and so the structure is in a better mode or in a safer mode. What the Center Water Commission says or defines large dam as? It defines a dam is classified as one with a maximum height of more than 15 meters. Okay, fine. This is the one which we adopted from the ICOL bulletin. Further, it qualifies that a dam between 10 to 15 meters in height from its deepest foundation level is also included in the classification of large dam, provided. There we were talking only of one condition about the reservoir, but then Center Water Commission, looking at the structures which are coming up in our country, it further classified that a dam which is having a crest length of not less than 500 meters will also be classified as a large dam. Capacity of the reservoir found by the dam is not less than 1 million cubic meter. There we were talking about 3 million cubic meters, but here we again classified them as 1 million cubic meter. Or the maximum flood discharge dealt with the dam is not less than 2000 cubic meter per second, or the dam has especially difficult foundation problems, or the dam is of unusual design. Now, if we look at all these the categories, the question comes to our mind is why? Why should we go in for such a complex definition of large dams, even though the ICOL, which is the International Commission of Large Dams, which is internationally known, has simplified the definition of large dams to only more than 15 meters and 3 million cubic meter. Why at all? Because if we see the geological formation of our country, see, we are a plateau. So we are having a plateau. It's a peninsula. Basically, India is a peninsula. So wherein we are having very young mountains, that is the Himalayas. The geology which is really very young. By very young means a lot of activities are occurring. Lot of geological activities are occurring. The structures or rather the foundations of the structures which we are building is still they are at times in very fragile conditions also, and there are many geological surprises. So looking at all those things, and also we at times are getting continuous rainfalls, and those rainfalls are even causing floods. So all these things have been taken into consideration. So what we take, we said, okay, we took reservoir also one of the criteria. Then we took that the crest length is more than 500 meters, another criteria, because if the crest length is going to be high, then there can be, this means we are going to form the dam in a relatively wide valley. Then only then we'll be having a crest length of more than 500 meters. Secondly, we are also taking into consideration that floods, because floods create a lot of havoc in our country. The reason why floods are creating havoc, why floods are not creating havoc in other countries, because also that we are a highly populated country also, and since times immemorial, since ages, all the civilizations have developed along the rivers. So end of the day, if there is going to be flood in the rivers, this is going to be affecting the human life. So we kept flood also as one of the criteria. Then we also qualified that in case we are going to have some difficult foundation problems. What do you mean by difficult foundation problems? There are shear zones. There are varied type of rock types. Maybe the most suitable location which you identify to have your dam constructed is consisting of two or three types of rocks which are coming in the foundation of the dam, and the deformation characteristics of all those rock types are going to be different, and so my dam structure is going to be different. It's going to behave differently. So we took foundation also into one of the criteria, and over and above we also qualified is as in case the structure is going to have some unusual design. So with these we qualified, okay, these are the criteria with which we will be qualifying that the dam is going to be a large dam. If we see the register of large dams of ICOLD, this is showing that around 60,000 dams have been built all over the world. The numbers may be a little bit plus or minus, not much is going to be agreeing. See, dams are slow structures. Means, what do you mean by slow structures? Means, these structures are usually formed in a period not less than 3 to 5 years, and maybe even at times moving to 20 years, 25 years or 30 years. So I'll say that these are slow structures. So and if we see the classification of different types of dams which are built world over, we will see that the major component or the major part or the major types of dams which are built world over are earthen dams, followed by rock-filled dams, gravity dams, arch dams, and other types of dams. What are the other types of dams which we can think of? Maybe we can talk about GeoFRD. GFRD is geomembrane faced rock-filled dams. Then we can have CFRDs, concrete faced rock-filled dams. We can talk about asphalt core dams. So these are the different types of dams which we can talk about. We can also talk about something we also say coalcrete dams. So these are different types of dams, but majorly world over we are talking of earth dams, rock fills, gravity dams. Arch dams are relatively less because arch dams require strong foundation, strong abutments, because it is by the arching action that we are trying to distribute the load which is going to come on the dam face into the abutments. So this means that earth dams are important, and because earth dams are majorly used, so more important is the material with which we are going to build these earth dams, and that is the soil. And that is why also when CSMRS and Nihari decided to organize training programs, we said that let us focus on soil investigation and rivers and river protection works. This will be the major area in which we will be trying to focus our training program. So with this I called, and then if we go in for the earthen dams or the earthen rockfill dams. So basically earthen dams and earthen rockfill dams. In both these dams, the only material which is going to stop the loss of water or is going to be used to store the water is the soil. Okay, soil is going to be acting as the impermeable material in earth dams as well as earthen rockfill dams. Now let us see some of the highest earthen rockfill dams in the world. Usually the concept, the people who are not working into the dam engineering, they feel that okay, with the soil you can build a dam maybe of 5 or 6 meters or maximum of 20 meters or maximum of 30 meters. But no, if we see this highest dams, we are having heights of 335 meters high dams. Then 300-meter high dam. This is in Kazakhstan, then in China. Mexico 262, again China again 262, and in India the highest earthen rockfill dam is the Tehri Dam. And Tehri Dam in itself, as I was saying previously also, that dams are slow structures. It took a very long time for this dam to be constructed because There were two major challenges for the engineers as such that we are going to build a dam in a highly seismic zone. Highly seismic zone means we were even expecting that there may be a possibility that a earthquake of magnitude 8.1 on the Richter scale may occur. And in case such a magnitude of earthquake occurs and my structure fails, then the water which is going to be impounded in the reservoir of Tehri Dam will be wiping off even Delhi. From Tehri to Haridwar to Delhi. So, because ultimately through this, then to the Yamuna, and finally that was the idea. So, it was a real challenge that how we are going to build a dam which can resist that level of seismic forces. We'll take up the quality control for Tehri Dam also in this lecture. So basically, we can see that yes, we have built dams of magnitudes which are really large or really huge. So some people will say or may say that maybe this is possible only in countries where technology is high, and that maybe we engineers are not exposed to that technology. But it's not the technology alone; it is the willpower of the engineers of our country also, and the meticulous planning which we had done using the construction of this that we have achieved such heights. Now, let us see what are the different types of dams in India. The large dams, again, and its distribution. We see that majority of the dams have been built in Maharashtra. Why have Maharashtra so many dams? Can somebody think of any wild guesses? Okay, one answer is it's a big area, Maharashtra. Population. Population, okay. वहाँ का mainly जो source है पानी का वो बरसाती पानी है जिसको रोकना होता है ठीक है जैसे गंगा हुई वो ग्लेशियर जोर्स में 12 महीने तक ठीक है इसलिए ज्यादा है दूसरा क्या हो सकता है छोटी छोटी सी रिवर्स एंड रिलेटिवली फ्लैट एरिया अभी क्या है कि व्हेन यू आर टॉकिंग अबाउट द हिमालयन रीजन इफ यू सी द हिमालयन रीजन देन यू आर गेटिंग नैरो गॉर्जेस है ना नैरो गॉर्जेस आपके हो जाते हैं एंड इफ यू क्रिएट अ डैम यू हैव अ बिग रिजर्वायर आपने एक हेड बनाई यू हैव अ स्लोप बेसिकली यू आर हैविंग अ स्लोपी टेरेन सो बिकॉज ऑफ द स्लोपी टेरेन आपने यहाँ पे एक डैम बनाया आपके पास रिजर्वायर आया आप फर्दर 4-5 किलोमीटर डाउन स्ट्रीम में गए एंड देन यू पुट अ पावर हाउस यू कैन जनरेट लॉट ऑफ इलेक्ट्रिसिटी बिकॉज इट इज दैट हेड डिफरेंस विच इज रिक्वायर्ड फॉर जनरेटिंग ऑफ इलेक्ट्रिसिटी नाउ दिस इज रीजन a relatively flat region so you are going to have number of small dams so the numbers are very large so this is the distribution of the dams in our country and the next is which one Gujarat so Maharashtra then Gujarat and even Madhya Pradesh and these are the regions where we are not having relatively or we are having relatively lesser mountainous ranges so this is and again this is the number of large dams from the National Register of Large Dams again and under construction if we see also then also it is Maharashtra which is topping the list of the dams which are being constructed in our country. Let us try also to see that how the dams have been built in the country over a period of time. So we see that up to 1900 very few dams means 67 dams were there. Then 1900 to 50 means in the next 50 years around 300 more dams were constructed. In the next 50 years again around 300, 200, 236. Then if we see that from the 1970s to 1990s we will say in the next 20 years the dam construction took a lot of pace and this is when our economy was expanding we required more of water resources we worked on the green revolution and all these things were developing Now, this is one of the oldest dam in our country. If we don't read what is written there, then can you expect what how old it can be? This dam was constructed in the 2nd century AD. And the best part is the dam is still working, it's functioning. There are no cracks. It is the Grand Anicut. And this speaks that we, even at that time, it's so 2nd century means how many years? Hmm? More than around 2000, है ना? And it is working fine. So even at that time, we were knowing that the importance of quality control is there. And it is because of that good quality control and good construction practices that this structure is still working. Otherwise, somebody may feel so old, how it is possible. And when as designer also, we when we talk, we'll say what is the life of the dam. We'll say okay, 100 years. And 100 years we are very much satisfied with by saying okay, we are going to build a structure for 100 years. It's good. Means 2 generations it will be able to see. It's fairly good enough. So this is located on river Kaveri. Not much high, 5.4-meter high, 329-meter long with a base width of 20 meters. Some improvements were made in the 19th century by Sir Arthur Carton, and it is giving a lot of it is the basically it is providing the major source of water to that region. During the construction, the foundations were basically compacted using elephants because we were not having rollers at that times, so earth moving machines were not there, so elephants were used to compact the foundations. They were knowing that the foundation has to be compacted in layers. They were knowing that what should be the density which is to be required, and that is how the whole thing was designed and made. Now, when we talk about dam failures, why dam failures? We go by reverse engineering. I'll show you some examples wherein poor construction or poor quality has led to certain failures, and then we will go into what will be the importance and how to maintain those quality control. So if we talk about an earthen dam, what are the different types of possible dam failures? The most important thing to understand is number one, that at many of our structures we are allowing trees and bushes to grow in. Now somebody will say what these tree and bushes are going to do with my dam. Okay, these are part of the thing. It's eco-friendly. It's nothing wrong in it. The problem is that these trees and bushes which are going to be grow on the surface of the dam are not a permanent thing. So means after 4 years or 5 years, once these trees die or these bushes they wither off, their roots are going to rot and they are going to create spaces in the dam body, which may be possible seepage paths, and which may lead to failure of these structures. So one thing which we all need to be careful is that no big trees or bushes should be allowed to be grown on the surface or the structure of the dam. Then at times there can be rodent activity also. You may feel a bit funny about it, but yes, there have been cases wherein the rodents and series of rodents have been able to create paths all across the earthen dams, thereby then leading to slight piping sort of thing and leading to lot of erosions. We can have seepages at the abutment contacts. We can have some slumping failures. These all things, suppose you are going to visit your structure, if suppose you are in charge of certain structures, when you are going to visit your structures, these are things which we need to be looking at. And in case any of these things are there, come to our knowledge, then some corrective measures should be taken up immediately. There can be cracking. There can be lowering of the crest of the dam body, which indicates that there is settlement of the material. There can be cracking near the concrete structure. This pointer is not working fine actually. And there can be piping failure, there can be stability problem, there can be erosion, there can be boils on the downstream, and all these things or anything which is unusual which is occurring in your structure can be leading to or can be a cause of failure of the structure, not immediately but maybe in the near future. So when we are visiting our structures, when we are going to our structures, then we should look into all these activities or all these things. कैसे कैसे tree and bushes. Okay, so suppose you are having a structure and some trees have been growing on it. Two things are going to happen. Number one, the trees are going to have roots. So what will happen, these roots will be expanding. जब पेड़ की जड़ें बढ़ती हैं, so what they will do, they will be trying to move paths into the your dam body. Over a period of time, what will happen? Ek to these trees are also going to attract some animals, some burrowing animals. Ek to this happens. Then suppose these roots rot over a period of time. सड़ जाती हैं जब कुछ जड़ें सड़ गई. So what is going to happen? You are going to create spaces there. अब आपका सपोज एक डैम था, मे बी इट वॉज 4.5 or 5 or 7 meters हाई डैम. ठीक है, अब उसके अंदर आपने कोई ऐसा पेड़ लग गया. अब अगेन इफ यू गो इनटू the biology of it, rather the zoology or botany of it, then some trees are having the fibrous root system, some are having tap root system, है ना, जिसमें कि जो roots है बिल्कुल नीचे तक चलती चली जाती है. तो हो सकता है कि there is a neem tree which is having a root which is going to up to 4 or 5 meter depth or 3 meter depth. अब वो वहां पर जब खराब हो गया, सड़ गया, तो उतना तो आपने एक स्पेस बना दिया ना उसके अंदर. अब जब स्पेस बन गया तो फिर क्या होगा कि वहां से पाइपिंग इनिशिएट हो सकती है ना. सो वो हमें बिल्कुल अलाउ नहीं करना चाहिए. हाँ, there is a philosophy which is saying that these roots are going to be acting as erosion control measures. But the main thing is that bushes are not going to be permanent. That is the main thing. It will be acting temporarily. So even at many of the places in embankments, these things are being placed. But for that case, even there are certain bushes called vertivers, wherein है ना, उनका जो ग्रास जो होती है उसको रूट डेप्थ काफी है. But then we need to take care that those vertivers, if they are going to be planted, वो regularly रहे. So you have to take care that way. टर्फिंग करते हैं, तो टर्फिंग में हमने क्या किया, सरफेस इरोजन को हमने वो कर लिया और उसकी रूट जोन छोटी सी रही. आई एम टॉकिंग अबाउट रूट जोन विच इज गोइंग टू अप टू मे बी 1 meter डीप, वहां तक जा रही है. क्योंकि या तो वो परमानेंट हो, वो यूजुअली वी आर अनेबल टू डू. नॉर्मली बुशेज व्हाई दे आर ग्रोइंग बिकॉज ऑफ द नॉट अटेंशन ऑफ आवर्स. वो एक बार उगना शुरू हो गया, फिर उसके बाद फिर वो जो है nobody is going to take care of it, and that causes the problem to our structure. One fine morning क्या होता है कि वो आप वहाँ पे विजिट पे गए, फिर आपने देखा अरे यार ये तो पेड़ इतना बड़ा हो गया, अब क्या करें. Now you cannot cut it because now it comes under some different rules and regulations. So finally you come into a situation where you can do nothing and you can just see कि अच्छा डैमेज तो हो रहा है मेरे स्ट्रक्चर को. तो वो all those things come into picture. स्लम्प हम लोगों ने एक्चुअली डैम डिज़ाइन वर्ड नहीं हमने यूज़ किया. इफ़ वी टॉक अबाउट डैम्स, इसमें हम लोगों का जो बेसिक व्हेन वी डिज़ाइन एनी डैम, तो उसमें हम लोगों का जो बेसिक आइडिया रहता है ड्यूरिंग डिज़ाइनिंग इज़ कि जो फेरेटिक लाइन है, फेरेटिक लाइन क्या होती है, यू आर हैविंग अ स्ट्रक्चर, उसका अप स्ट्रीम में आपने पानी को रोका, पानी धीरे धीरे सीप करेगा डैम बॉडी में और डाउन स्ट्रीम में आपको थोड़ा बहुत पानी निकलेगा, है ना, जिसको कि हम फिल्टर्स के थ्रू कैच करके उसको हम ट्रेन करके बाहर ले जाते हैं. दिस इज हाउ द डैम इज बीइंग डिजाइन. तो समटाइम्स व्हाट हैपेंस इज कि जब हमारे फिल्टर्स इफ दे आर नॉट फंक्शनिंग टू देयर मैक्सिमम और टू द इंटेंडेड रिक्वायरमेंट्स, तो क्या होगा कि वाटर जो है वो आपके डाउनस्ट्रीम टो को पर क्रॉस करेगा। इसका मतलब क्या होगा कि मेरा डाउनस्ट्रीम साइड ऑफ द डैम, मतलब ये पोर्शन जो है मेरा डैम का, ये पोर्शन ये सैचुरेटेड है, मैं ऐसे है ना। आपका बेसिकली क्या है कि आपकी फेरेटिक लाइन, अगर ये मेरा वाटर सरफेस है, तो फेरेटिक लाइन शुड कम ऐसे, और रॉक टॉप पे उसको मिल जाना चाहिए। या इफ आई एम गोइंग टू हैव अ वर्टिकल फिल्टर और ये इंक्लाइन फिल्टर, मैं फेरेटिक लाइन शुड मीट दी इंक्लाइन फिल्टर, और इंक्लाइन फिल्टर से होकर मैं पानी को बाहर ले जाऊं। अगर मेरा ये इंक्लाइन फिल्टर चोक हो गया, so what will happen, this water will be coming on the downstream face of the dam। तो डाउनस्ट्रीम फेस में जब आ गया तो क्या होगा कि ये मेरा पोर्शन मेरा सैचुरेटेड, जब सैचुरेट हो गया, so what will happen that उसकी shear strength कम हो गई। अब मेरा डिजाइन स्लोप था बेस्ड ऑन सर्टेन shear strength, ठीक है, और वाटर प्रेशर भी लग रहा है, वाटर प्रेशर लग रहा है, shear strength मेरी कम होगी, तो क्या होगा कि वहां पर स्लंपिंग होगी, मूवमेंट होगा, कुछ हो सकता है आपका जो है वहां पर मिट्टी बैठ गई। अगर आप when you are going to visit the structure as such, so you will see that this particular slope में आपको कुछ undulations मिलेंगे। Those undulations are indication that your ferritic line is somehow coming to the downstream side of the structure। तो अब उसके लिए आपको जो है कुछ remedial measures लेने पड़ेंगे। Now what remedial measures you can take? This is a big topic, because then you have to go in for maybe either you go for additional slope, or you may try to intercept this ferritic line by some other means। तो आप उसको काट के या तो दोबारा से रिबिल्ड कीजिए और वहां पे फिल्टर जोन लगाइए, या फिर आप उसके ऊपर एक एडिशनल स्लोप बनाइए। मींस व्हाट आई कैन डू इज आई कैन मेबी कट दिस मच पोर्शन ऑफ द डैम बॉडी, lay my filter again and rebuild it, or I lay a filter here and then rebuild the dam। This is the only way I can do। Filters में again we can go in for either sand filters, which can be again encompassed between geotextile, non-woven type of geotextile, both upstream and downstream। इस तरीके से भी I can go in for it, ठीक है। So when you are going to visit your structures, if we are going to find any of these which is some unusual things, then we need to be a little bit precautious and we need to monitor it first of all। It's not that कि as soon as you see a distress immediately आप उस पर काम करना शुरू कर देते हो, because the cause of the distress is not known। So it is by monitoring and regular visiting that maybe you can come on to certain conclusions, okay, this is the reason or this is the phenomena which is causing this distress, and then you start working on the phenomena। So the cause has to be eliminated, the cause and the effect, so the cause has to be eliminated, so you work on the cause and finally you see that the effect is diminished। These are some of the structures I mean which have failed internationally, they have failed। It's not that we don't make mistakes, we make mistakes। What are these mistakes? The mistakes are usually our lack of understanding or lack of investigation, lack of following the correct construction practices, which have led to certain failures। And usually earthen dams, most critical time is the first reservoir filling। The first reservoir filling is usually the most critical time wherein maximum care has to be taken of the structure, because structures have shown failures during its first reservoir filling। Why? Because you constructed a dam, at certain OMC and density, now the structure is ready, and now you start filling the dam and the material gets saturated। Now imagine a dam which is maybe some, okay, let us imagine a kilometer long earthen dam. It has been built over a period of time, so height wise as well as length wise there can be material variability, Then can be variability in the construction practice. There can be variability in the borrow area material, and there can also be variability in the moisture content which has been put into the material when it was being laid. So even though we as design or in the drawing we feel that okay, the structure is uniform, actually it is not uniform, and that non-uniform structure is now subjected to a constant water load. The profile is also variable. The valley, you don't get a square valley, है ना? So you will be having a U shape or a V shape valley, and so the profile is also variable. The load which is coming at different sections of the dam is also variable, and so it is going to be subjected to different types of forces: lateral forces, horizontal forces, vertical forces, and so these structures have certain failures which have been seen. So if we see here, uh, we have structural failures, we have foundation failures, we even have overtopping due to flood. So you just, if you just read the reasons, you automatically will be able to understand that okay, what are the different or where we were lacking as engineers, where we were lacking. Like structural failure means that our construction quality was not good, or our design was somehow not up to the mark. Foundation failure means that my foundation treatment was not good. Maybe I could not provide the real cutoff for the dam. Maybe my foundation grouting was not up to the mark. Maybe the grouting which I carried out as a consolidation grouting or as a cutoff grouting for the cutoff was not meeting the depth to which it had to be done. Overtopping during flood means my assessment of the hydrology was wrong. Or maybe I designed my structure for 1 in 50 years or 1 in 200 years and I got a 1 in 500 year flood. Okay. Then this is a case of the Wyont Dam. Here actually the dam didn't fail. This has been taken as a classic failure case in the history, international history. But here the dam did fail. It was a double arch dam, and if possible, after our lecture, you just search it. It's really good to learn about how and what happened. Uh, Here the valley was very promising for an arch dam, and the engineers they planned okay, we can go in for a double arch dam like a shell structure wherein there was arch in this direction as well as arching in this direction. But the region in which this dam was constructed was having lot of landslides. Lot of landslides used to occur there. But lot of engineering was done, lot of designs were carried out, and it was thought of that okay, what we will be doing is that we will be monitoring the landslides, and in case such a slide is going to occur, we will be just lowering the reservoir. This is how the whole things were planned up. And here the foundation of the structure, rather upstream of the structure, the mountains were having alternate bands of limestone and clay. And what happened was that as soon as they filled up the reservoir, the water that entered through the joints of the limestone and it saturated the clay mass. And once the clay zone was saturated, you understand, suppose this is my mountain and I'm talking of a cross section. If this is my mountain and there is a clay band here and this is also limestone, upper is also limestone. So as I'm filling up my reservoir, this limestone is getting saturated and this limestone is then saturating the clay here. The clay, it reduced in its shear strength, and so what happened? This whole mountain started moving. So the engineers there, what they did, they reduced the reservoir level, and thereby the movement of the mountain was It came to around maybe 0.5 centimeter per day type of a thing. Again, they filled up the reservoir little bit more, and they found that with every consecutive reservoir filling and lowering, the movement was reducing. So they became more and more confident that okay, the geology has come to a certain equilibrium, and then we can operate the structure the way we want. And then one fine morning in this 1963, when this structure, rather this failure occurred, a whole mass of mountain, it started moving, and even when they were trying to lower the reservoir, the movement came to they have recorded in the in some of the journals. हाँ? आएगा आएगा इंडिया में भी आएगा 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 इंडिया में भी आएगा failures are not international, failures are everywhere. And this whole mass of mountain, it moved up to a maximum speed of around 90 kilometer per hour. So before they could lower the reservoir, this whole mass of soil, it came into the reservoir, and a huge wave, a wave of around 200 meters of water, it was created, which swept the downstream side of the structure, and the reservoir is now filled up with whole soil. The dam is standing, but today it is only a tourist place because that whole reservoir, whole soil mass is covering it, and the dam is standing. The dam was structurally safe, but what I am trying to tell here is that it's not only the structural planning, but it is the holistic planning which is important when you are going to conceptualize for a structure like a dam. If we see here also some of the failure modes. We have failure modes of piping. ये देखिए हमारा पेन ये भी फेल हो रहा है. When we are talking of failures, this is also. So we have piping, overtopping. Majorly अगर आप देखते हैं तो piping, overtopping, little bit of seepage. This is occurring here. Or these are earthfill, rockfill dams, earthen dams, and we can see that even इंडिया में भी आगे देखिए आपको 6 नंबर पे देख रहे हैं. सो कदम डैम ओवरटॉपिंग गया हमारे पास. एक माचू डैम में सीपेज हुआ 74 to 79. ठीक है. और यू ऑल्सो सी द फेलियर टाइम 1 घंटा 2 घंटा मैक्सिमम वी आर लुकिंग एट 12 hours 7 hours 3 hours. So as engineers you really don't have time to even work on it. अभी if we look back अभी very recently तो सिस्ता 3 हमारा डैम गया जो एक ग्लेशियर लेक गिरने की वजह से ब्रेकआउट की वजह से तिस्ता 3 डैम फेल्ड है ना. अभी हुआ है अरुणाचल में हुआ है 2-3 साल पहले. सो सिक्किम में हुआ सॉरी है ना. सिक्किम में हुआ ना. वी डेंट हैव टाइम टू डू एनीथिंग. दे वर ट्राइंग टू ओपन द गेट्स दे कुड नॉट रीच इट देयर. Exactly. So basically क्या है कि even as engineers when you are designing the structures many times there are certain phenomena which are beyond your control or beyond your imagination or even beyond your conceptualizing it. आप एक पर्टिकुलर फ्लड के लिए डिजाइन करेंगे, एक पर्टिकुलर उसके लिए डिजाइन करेंगे, बट नेचर के फ्यूरी के आगे यू कैन डू वर्चुअली नथिंग एट टाइम्स. तो वो भी है, बट वी ऑलवेज ट्राई टू डू द बेस्ट एंड ट्राई टू डिजाइन फॉर द बेस्ट ऑफ इट. सो व्हाट हैपेंड इन इंडिया. हमारे यहाँ पर भी कुछ डैम्स का फेलियर हुआ और लगातार होते चले गए और वी ट्राई टू लर्न फ्रॉम इट, बट स्टिल देयर वर गैप्स, देयर थिंग्स हैपेंड. And the last which occurred was Garada Dam. I'll also try to cover it in my presentation. This occurred in 2010. This dam has been rehabilitated. It has been built back. So in all these cases also, majorly अगर हम देखते हैं तो piping, overtopping means क्या हुआ कि हमारा flood जो हमने सोचा था वो ज़्यादा आ गया. That is one aspect. That is something okay you cannot control. But पाइपिंग क्यों हुई? पाइपिंग तो इस वजह से हुई ना कि हमारा डिजाइन या कंस्ट्रक्शन इन दोनों में गलती हुई. अब यूजुअली डिजाइन में गलतियां कम होती हैं. देयर आर लेस मिस्टेक्स इन डिजाइन. यूजुअली देयर आर लेस मिस्टेक्स. डिजाइन में मिस्टेक्स कब हो सकती हैं? There can be mistakes in designs if we are unable to evaluate two things: the material which we are going to use for construction and the foundation. अगर ये दोनों चीजों के evaluation में there is error, then there can be error in the design. Otherwise, majorly what will happen? There will be error in the construction. Okay, so now let us see some generic causes of structural failures of that. Some generic causes, they have been classified as project planning. Project planning means lack of clear scope or conflicting client expectation. You started with conceptualizing a dam as a concrete dam. You created your DPR. Based on the DPR, आप आगे बढ़े, आपने money sanction कराया. And where you lagged in was that you lagged it in the initial investigation. When you came in for the construction or the pre-construction stage, then you did your investigations and you found out that the foundation which you are planning to bear the load of a concrete dam is problematic. अब आपको क्या करना पड़ेगा? अब आपको जाना पड़ेगा Earthen dam पर. Up for the Earthen dam, you don't have the material. So now what to do? अब आप फंस गए. Now you are into a fix. If you are going to try to find out the good construction material, आपका कॉस्ट बढ़ जाता है. अगर आप कंक्रीट डैम की तरफ जाते हैं, क्योंकि अभी क्या कहता है, फॉर द कंक्रीट डैम आपने क्या, यू हैड सर्च फॉर एग्रीगेट्स. कंस्ट्रक्शन मटेरियल तब क्या हुआ, आपका एग्रीगेट्स हुआ, सीमेंट एग्रीगेट, यहां तक आप पहुंचे तो आपने एग्रीगेट की क्वेरी ढूंढी. और जब अर्थ डैम पे गए तो आपको क्या ढूंढना है, सॉइल चाहिए. क्वांटिटीज डिफर. कंक्रीट डैम आर हैविंग लीनर स्ट्रक्चर्स, लीनर आपके वो रहते हैं सेक्शंस, है ना. अर्थ डैम्स के आपके सेक्शंस बड़े रहते हैं. इन अर्थ डैम्स वी टॉक अबाउट स्लोप्स ऑफ 1:2.5, 1:2, 1:3. और कंक्रीट में कितने की बात करते हैं हम, 0.75:1 or 0.25:1. So we have a vertical face and 0.75:1. So 0.75:1 से 3:1 पे पहुंच गया. ठीक है. So quantities vary. आपका सब कुछ चेंज हो चुका है. Then site investigation, inadequate scope or extent of ground investigations, misinterpretation of information. Now somebody will say कि interpretation कैसे miss हो सकता है? How can be there be misinterpretation of the information? What is the information you get when you are going to conceptualize structure? Your borehole investigation, your geological investigation. And in case you are going to have the investigation done through an agency which is not even able to drill a good borehole, you will be coming in a different type of geological informations. There has been a structure which has been conceptualized in the Andaman. Basically, two errors I would like to tell you people. One error was made in the surveying. You may think how survey can be wrong. Nowadays we are talking about total stations, and we are also having good softwares wherein you give labels of two places and it automatically creating contours. So what they did was, at that particular project, that there was a hill which was something like this. Okay, the hill slope is, I am talking of a section, the hill slope, you are having a top, then it was a near vertical fall, and then the hill was going like this. Okay, so the surveyman, what he did, he took a point here and he took a point here and he gave it to generation of contours. Now, how the contours will be formed? From here to here, the contours are showing that this is the hill mass, and actually the hill mass is this way. Okay, so the drawings they came down to Central Water Commission, and it was planned that okay, we are having a good abutment, and so we can go in for a concrete dam. Fine. But then the geological exploration started. And incidentally, this I am talking in the northern Andaman. I don't know if you people have somebody have gone to Andaman. So Andaman, mein, if you go to the northern part is it is the northernmost tip, hai na? So it's difficult to even go there. Port Blair is easy. You take a flight, you go to Port Blair. So in the northern part of the Andaman, it becomes really difficult. And the drilling agency which reached there, what they did was that the machine which they were having was not of a very good condition. Rather, the drilling head in itself, it was not secure to the machine. So what happened? When they started drilling, this drilling head is moving like this. Okay. So once the drilling head is moving like this, what will happen? When you are going below, it is going to break the rock cores. Fine. So finally you get a core box which is having lot of fractures. So now this geological information is going to come to the designer. Suppose you are sitting as a designer. So you get a rock core log which is showing an RQD, a poor RQD. So now what will say? Why we cannot go for a concrete dam. Fine. Initially the abutment was showing that you can go in for a concrete dam also. Now the rock cores are saying that I cannot go for the concrete dam because the foundation is very poor. So now what to do? We'll go for a earthen dam. Fine. So then the investigation started for the earthen dam. Borrow areas were identified, materials were tested, everything was completed. Now came in that let us plan the construction of the dam. So then a visit was carried out there. Now agencies involved, Central Water Commission, CSMRS, GSI. So GSI is looking at the geological formation, Central Water Commission is looking at the designs, CSMRS is looking at the bore area materials. So when we reach there, and now see how these things are affecting the whole structure. When we reach there, we ask the project people, by at least clear the bushes, we want to see the abutment. So when they cleared the bushes, basically we found that this is the hill slope is coming like this. So our basic planning of putting the earthen dam which will be abutting to this abutment was failing. The rock cores are showing that you cannot go for a concrete dam. The survey which showed that you can go for an earth dam is now failing. Then we had interaction with the survey people. By how you did the survey? Sir, nowadays it is total station and we simply took this. What were the levels at which you had taken these level points? At what distances? What difference of levels? Sir, 100-meter levels we had taken, and so simply it was developed. Then we took the surveyor again to that point. But you see here now. These are certain problems which actually are not even recorded at places, and still that project is its fate is still hanging in indefinite region. What will happen and what type of dam to be constructed. So site investigation and misinterpretation of information. Then design errors, conceptual design errors can be there, lack of redundancy, failure to identify all loads and load combinations. Calculation errors can also be there, detailing deficiencies, specification deficiencies, failure to consider surveillance, monitoring and maintenance. Construction errors, inappropriate temporary works. Your coffer dam is not appropriate. आपने सोचा था ये फ्लड को कर लेगा और डाइवर्जन टनल मेरी काम कर जाएगी. It didn't work that way. Recently a case has come to us in which the divergent tunnel has collapsed. Why? Certain portion of the divergent tunnel they didn't provide the support, thinking the rock mass is good here, and that was error in the qualification of the rock mass. The rock quality was class 4, and so which they had misinterpreted as class 2 rock. So the divergent tunnel has collapsed. The coffer dam has overtopped. The dam pit area is full of water because now you are having two coffer dams, upstream and downstream, and DT is collapsed. So overtopping is occurring. Material deficiencies, material inconsistency can be there, premature deterioration or fabrication defects. Operational errors can be there, structural alterations, operations beyond the scope of the design, changes in structural use, inadequate surveillance, monitoring and maintenance. These can be some of the generic causes for structural failures of the dam. We are discussing them in detail so that little bit of it remains with you people in your memories, and in case you are going to come into such areas, then you will be taking care of it. Then in overtopping, it can be either two ways, either insufficient spillway capacity can be there, or there can be extreme flood exceeding the design criteria. Quality piping in the body can be there, sliding of the dam body, piping in foundation, piping around spillway, quality issues in spillway, piping around culvert and other embedded structures, quality issues in culvert and others. Poor management, decrease of reservoir capacity for flood control due to over storage prior to flood season, poor management and operation, organization issues, nobody responsible for the management of the dam. This is the construction team. This is the team who is going to look after the guest house. And this is the team who will look after when some dignitary is going to be visiting. But there is no team to look after the dam, for which this whole structure is there. Poor construction planning and scheduling. There can be disasters also. Okay, there can be earthquakes, there can be war, breaching of the upstream dam, there can be rodent den also. Rodents can cause failures in earthen dams. Usually people never think about it. They say, how can a small mouse fail a structure which we have created? But they have happened. There can be spillway blockage due to bank slide in the reservoir, breach due to excavation on the dam for discharging, or poor planning of the general layout of the project. So things happen that way. Especially structures which are low in height, there certain problems are more, because there what happens is that we are in an overconfident state of mind that okay, we know about it, and it's only maybe a 5 meter or 6 meter high structure, and we have built a lot of it. So statistically we see overtopping, and maximum if we see we are having quality problems. If we try to analyze the dam failures, the maximum they are occurring because of quality problem.
So what looking at the main reason design पे blame आएगा ना, क्योंकि insufficient spring में तो design से ऊपर depend करता है.
So what happens is that yes, in certain cases two things are usually occur. In case ऐसा कोई failure होता है, suppose कोई structure ऐसा fail हो गया, तो obviously उसके फिर कुछ some investigations will be done, and design is something which can be checked. Then because suppose flood has occurred, तो flood का भी दो aspect आता है. एक तो spillway की capacity आपको पता चल गया, है ना, वो आपके पास रहता है. फिर आपका फ्लड फोरकास्टिंग भी होती है, रिटर्न पीरियड भी आप निकालते हैं. तो क्या है कि डिजाइन फ्लड भी जो है वो स्ट्रक्चर की इंपॉर्टेंस के हिसाब से होता है ना. अगर इम्पोर्टेंट स्ट्रक्चर ज्यादा है तो आप डिजाइन फ्लड आप 100 ईयर्स का ले लो. होता है होता है,
क्योंकि नेचर तो 30 साल 50 साल मेरे को वैसा डिस्टर्ब करता है।
होता है. Many a times it also happens is that uh, you don't find any reason, so you say finally it is because of the overtopping. है ना? That also happens. So but yes, overtopping में वही है कि at times हो सकता है कि आपका डिजाइन इनएडिक्वेट रहा हो, स्पिलवे कैपेसिटी आपकी इनएडिक्वेट रही हो सकता है आपके गेट ऑपरेटिव ना हो सकता है आपके गेट चोक हो गए हों, हो सकता है कि आपका स्ट्रक्चर में थोड़े से हल्का सा कोई क्रैक्स हुए, आपको पता नहीं चला, कुछ गेट्स आपके इनऑपरेटिव थे, व्हेन द टाइम केम टू ऑपरेट देम वो फंस गए, वो यूज ही नहीं हुए, आपका हाइड्रोलिक सिस्टम फेल हो गया. मतलब देयर कैन बी मेनी मेनी रीजंस. इफ यू थिंक अबाउट इट यू विल सी अ वास्ट ओशन ऑफ रीजंस फॉर इट, है ना? मे बी उस पर्टिकुलर डे पर कोई नेशनल हॉलीडे हो गई, मे बी उस दिन कोई आपका देयर इज सम फेस्टिवल इज देयर. So there can be many many reasons. Who is the person to be blamed? That's a different issue. But things happen. Things happen that way. But majorly quality problem is one of the most identified also reason for major failures. Overtopping में तो you can say okay there can be different things, but quality में तो there is no answer to it. ठीक है. And percentage of sub causes of quality problems में which is leading to maximum again piping in the dam body or the foundation. Sliding of the body is relatively less. Piping around spillway again relatively less. Quality issues in spillway is less. Unknown causes 14%, but again piping. So piping means piping का मतलब क्या होगा? पाइपिंग आपने कल कवर किया था क्या थोड़ा सा? हैं?
वाटर से एक पाइपिंग पाइप के फॉर्म में आता है, अंदर से आपके स्टीम से डाउन स्टीम.
Piping means कि our particle has dislodged. Our particle has dislodged and has started flowing with the water. So वो क्या हो सकता है? अच्छा, अगर डिस्पर्सिव सॉइल होगी तो पाइपिंग होगी, है ना? डिस्पर्सिव सॉइल मीन्स कि सॉइल जो है वो पानी के कांटेक्ट में डिस्पर्स हो जाएगी और वो पार्टिकल्स का कोई भी कोहेसिव फोर्सेस बचेंगी नहीं और वो बह जाएगा वो. तो मतलब क्या हुआ कि हो सकता है कि ये दिस वाज द बॉर्डर एरिया विच यू आइडेंटिफाइड, इसमें से दिस वाज द यूजेबल टाइप ऑफ मटेरियल, दिस वाज द मटेरियल विच वाज टू बी रिजेक्टेड, एंड द कॉन्ट्रैक्टिंग एजेंसी में वो जेसीबी लेके आया, उसने 2 ट्रक यहाँ से भरे और वो ट्रक भर के उसने स्टॉक पाइल में डाल दिया, वो स्टॉक पाइल से आपने कंस्ट्रक्शन कर दिया, कॉम्पैक्शन वाज गुड, वाटर कंटेंट वाज गुड, but basically the material was the one which was rejected as such and it was used for construction, and so the structure simply failed. The structure was not knowing that you are using the wrong material, but it just simply failed when it was facing those forces of water. This is one of the case study. This is a classic case study which people usually refer, wherein the failure occurred, and it was a 93-meter high dam, and main issue was with the silt core. So yesterday we had learned that core किसका होना चाहिए? Core should be of clay. Why clay? अच्छा चलो बताओ, why clay? Impervious. आप परवियस बोल. Clay are impervious. Clays are impervious and they have cohesion. है ना? Cohesion means that the particles are sticking to each other. They have the tendency of accumulating with each other. They have a tendency of not flowing with water, not getting dislodged with water. So that is clay material. Silts क्या होते हैं? Silts में cohesion नहीं होता है, बहुत कम होता है. तो क्या होगा कि they have the tendency to flow with water. इसलिए whenever we talk about rivers, हम क्या बात करते हैं? Silt load की बात करते हैं. Clay load सुना आपने कभी? नहीं सुना ना? Silt load की बात करते हैं. Sediment management में हम silt load बात करते हैं. So silts are non cohesive type of materials, है ना? तो वो बह जाएंगी आपकी जो है. clays नहीं बहेंगी. So here the main core was made up of silt with sand and gravel outer zones. It was founded on layered and jointed rhyolite. Jointed rhyolite means कि my joints are having openings, उसके through मेरा material या water flow हो सकता है. Then the dramatic failure occurred during the first reservoir fill. What happened? This was the abutment. This is the abutment. Okay? ये abutment है, ये डैम यहाँ पर abut कर और इसमें सुबह सुबह when the engineers they were moving on the dam, छोटा सा एक सिंक होल मिला. एक छोटा सा सिंक होल मिला. So what they said कि भाई इसमें क्या करें, let us dump in some material into it. So they started dumping few bags of sand or silt type of thing into this. But they actually it was a case of piping failure. नीचे से मटेरियल जो है वो आपका जा रहा था. And actually on the downstream muddy water was flowing in. Then they tried to dump in more material on the downstream side also to restrain that flow of water. But nothing could be done. And slowly means within a matter of around they have recorded in 1.5 hours. 1 to 1.5 hours जो है this failure occurred. The whole dam body was washed away. Failures are usually taken as places wherein we can learn from our mistakes, and this is important, which we should done. We should do frequent visits to our structures. Abhi many times we feel abhi the dam has been built for 100 years. Even if we go once in 10 years, then also it is okay. But your structure, if it is going to fail, is not going to wait for you for 10 years. We have seen that major of our earth dams, if at all those failures have occurred, it has occurred in a period of maximum of 12 hours. Maximum of 12 hours. Even 1 or 2 hours also failures have occurred. So, if we are going to visit once in 2 years even, then also maybe certain things may be occurring which is unnoticed to us, and we will be when the incidence has occurred, then we will be saying, oh, maybe if I had come yesterday, I would have been able to salvage this structure. One more thing which occurred here was, in this particular case, was that the filter was not correctly designed. The filter was not able to secure the silty material within the section of the dam, and that is why this piping started. Secondly, we also learned that in grossly pervious and jointed foundation bedrock, single grout curtain should not be relied upon. So they had provided a single grout curtain, and actually what is grouting? You know what is grouting? How do we do? You drill a hole and then you inject cement grout into it. And we also feel that, okay, you do a grouting here, then you do a grouting here, then you do a grouting here, and then you do a permeability test. And the permeability test, if it is not showing any flow, this means we assume that this grout and this grout have met each other, and we are having a continuous impervious line of grout. So it is the most unengineered method of assessing the efficacy of grout. So in case your permeability test goes wrong, your whole grout design is wrong. How can the permeability test be wrong? Can you tell me? How can a permeability test be wrong? In one of the cases, we saw that the permeability test was wrong because the water meter was not functioning. Can you understand? The water meter which is used in the permeability test was non-functional Water was being pumped through, but it was indicating very less flow. ठीक है, अब आप सोचिए कि कहां पे गलती हुई, आपका वाटर मीटर काम नहीं कर रहा है. वाटर मीटर काम क्यों नहीं कर रहा है? बिकॉज द एजेंसी विच इज कमिंग, वो वाटर मीटर को लिया, वो स्टोर कर दिया, इधर फेंक गया, उधर फेंक गया, अंदर उसके कहीं पे समथिंग वो स्टक हो गया. अल्टीमेटली वाटर मीटर में क्या है, वाटर इज फ्लोइंग एंड सो दैट उसका इट स्टार्ट्स रोटेटिंग ना. इट इज द वेलोसिटी से आप उसका क्यू निकालते हैं, है ना. वाटर मीटर सिंपल होता है ना, व्हिच वी आर सीइंग इन आवर होम्स आल्सो. तो वो इट वाज नॉट फंक्शनल. सो अल्टीमेटली इट वाज थॉट के परमेबिलिटी तो बिल्कुल कम हो गया है, बट ग्राउट इनटेक हो रहा है. Permeability test is showing that there is zero permeability, but grout intake is there. So then it was decided that ultimately it is the water meter it is faulty. And how this occurred? This occurred when some team visited there. Otherwise तो कॉन्ट्रैक्टर को क्या प्रॉब्लम है, वो तो ग्राउटिंग करे जा रहा है, उसे तो कोई प्रॉब्लम नहीं है, अपना ग्राउट कर रहा है, उसका प्रोग्रेस हो रहा है वो जो है. Then deep narrow key trenches in bedrocks with steep slide slopes must be avoided, and bedrock cracks must be treated to avoid embankment core erosion. This is something we tried to learn, and this is now the dam as such. This is a spillway, and this is the poor quality of this cell. Okay. So, and इधर काम करता है, इधर भी काम करता है. So this is the spillway, this is the section. Here this was the apartment where it failed, and now they have abandoned it as such because structurally the foundation was not able to be built usable for building dams. Just out of context, have you heard alkali aggregate reaction? सुना? क्या होता है बताओ? मैं बताता हूँ. Okay, I'll help you out. There are certain aggregates which are reactive, and the alkalis, they are reactive when they come into contact with water, they expand. ठीक है. Now this phenomena was not known to the world in I think early 70s or late 70s. So by early 80s this phenomena was known. Before that it was not known to the world, I am saying. Not us, the world over. So structures which were built, some of the structures which were built before the 80s, they had aggregates which were reactive. And these alkali reactive aggregates, they used to expand, causing cracks in these structures. And aggregates will be used in concrete dams. So, and dams are going to be having a water face. So the aggregates in the dam body, they react, they form cracks, and once a crack is formed at the dam face, the more water is going to percolate inside, and so the aggregate which is further inside, it is going to crack, and more water is going to percolate, and finally you have heavy seepages. So even in the what I am trying to tell you is that engineering is also an evolving field. Even geology is an evolving field. So there have been structures wherein, based on the knowledge which we were having at that part of time, some structures were built. Some of them they worked, some of them they failed. The ones which failed, they gave us lessons, they told us that what mistakes we have done and how can we rectify them. This is another structure in China which failed in 1975, 24.5 meter high dam, and there were cracks in the dam and sluice gates. It appeared after completion due to construction and engineering errors were there. It was an earthen dam, and many people they died in this failure. So as you were saying that the failure modes, they can be from overtopping of embankment dam, piping through foundation, slope failure, erosion of slopes due to waters, waves or storm water. Then we move into what is quality. Okay. So what is quality? Quality is a term that relates to totality of features and characteristics of a product or a service that bear on its ability to satisfy a given need. कॉम्प्लेक्स डेफिनेशन नहीं समझ में आई फिर से पढ़ते हैं इट रिलेट टू द टोटलिटी ऑफ फीचर्स एंड कैरेक्टरिस्टिक्स ऑफ अ प्रोडक्ट मीन्स वी आर टॉकिंग ऑफ द टोटलिटी ऑफ द प्रोडक्ट सपोज वी आर टॉकिंग अबाउट दिस पॉइंटर so if we are talking about this pointer, if suppose I say whether this pointer is of ultimate quality or not, it is not only the functionality of this pointer, it is also its ease of usage, its ease of storage, its ease of replacing the cells in it, and the distance and the longevity up to which this pointer will work. That will define the quality of this pointer. Suppose I replace the cells in this pointer and the pointer is functioning only for 2 hours. I will say the quality of this pointer is not very good because the consumption of the cell is very high. Okay. Now I replace the cells in this pointer and it functions for maybe 10 hours. I'll say the quality of this particular thing is relatively better. Another thing which I also need to look after is that what is the weight of this pointer? Is it easy to use or it is so heavy that the person who is going to give lecture with this pointer will try to keep this pointer time and again. So we will say that totality of feature and characteristics of the product or service that bear on its ability to satisfy a given need. The need of the structure. So whether the totality is going to satisfy it, then we will say that the quality of that particular thing is okay. The concept of quality can appropriately be expressed as fitness for purpose. Is the thing fit for that purpose or not? You wear specs, is it fit for that purpose? Are you going to feel the weight of it? Are you getting tired of it? Is it going to create pain on your nose? Is it going to create certain irritation at your ears? So that all those things will be defining the quality. Quality assurance is thus all activities and functions aimed at attainment of the quality. You create a certain thing, X creates, Y sees that the quality is good, Z sees whether the person who is doing the quality control is actually doing it or not. So then Z becomes the person of quality assurance. He is assuring that the quality control is good and the quality control person is seeing that the thing which is being created is meeting the specified need or not. So this is how these things are there. So quality assurance is one level above the quality control. Okay. So again I'll repeat. I have a construction team. I have a team who is looking after whether the construction team is working as per the correct procedures or not. I have another team which is known as the quality assurance, which is looking at whether the checklist of the quality control people are correct or not and whether the quality control people are taking due care and at those particular times and intervals they are doing their job or not. So quality assurance is something above the quality control. There is another term called quality audit. This is done when things are completed, the structure is put into usage, and then you find that there are certain discrepancies, maybe small or big, then you go in for a quality audit. Okay, so we have the construction, the quality control, the quality assurance and the quality audit. So quality control refers to the operations, techniques and activities that sustain the product, service or structural quality to a specified requirement. It is also the use of such techniques and activities. QA includes but is broader than quality control. So if you are going to work in a quality control team, you have to devise methods which are going to be used to check the construction purpose or the performance purpose of the structure. Quality assurance is defined as all activities and functions concerned with the attainment of quality and implies the applications of various management techniques. Management techniques means how many quality control people are there? Are there overlaps in their time frame or not? Are they really qualified to look in the quality control? Uh, are they maintaining the records or not? Have the correct codes been taken into consideration to check the quality control? Have you seen that the limits which have been specified for those particular products taken into control or not? All these things will be taken care by the quality assurance people. Quality assurance is a step in an effort to assure that structure, service or product is fit for the purpose intended and that it will remain so for a stated period of time. QA is a wider term and is concerned with all activities from initial conceptualization through detailed design, manufacture, assembly, construction and erection, etc. till the finished structure system is put into use. Why I am repeating? Because we saw that even after people knowing about it, our maximum failures are occurring because of quality control issue. Sometimes this topic is a bit boring, but if you are able to get through this topic, then life becomes very easy. Okay. Then, as I was saying, quality audit. So, at intervals, the QA/QC procedures and inspections themselves are subjected to independent checking or audit. So, we are three people. He is the construction person, she is the quality control person, he is the quality assurance person, and somehow they all are not exposed to that particular level. So, they use some simple techniques to check. Okay, we will check this. And we'll say that the quality control is also called the quality assurance is called. So now the quality audit people will say, okay, you had used A, B and C only to check. You have to go in for up to D, E, F and G also. So these all aspects also have to be looked at. For example, I'll share yesterday during the geosynthetic lecture, I was telling that we didn't talk about it, that there is one thing called for defining the geosynthetic material, that is mass per unit area, or we say the GSM. GSM of a geosynthetic material. Now what is GSM? Mass per unit area, obviously. So what is the weight per square meter or per square feet of that particular material? Now, can weight qualify the mechanical properties? No. You have a cloth that the strength or the tensile strength of that cloth or the permeability of that cloth, if we talk about geotextile, the permeability of that cloth or the tensile strength of the cloth cannot be defined anyway with the mass per unit area. But we came across certain people who were saying, sir, we have put in our tender that we want to have a geotextile of 200 GSM only. So, and then they came to us asking whether this is correct or not. So we simply asked them, okay, how can you define a 200 GSM material to be qualifying for its tensile strength or the permeability or the apparent opening size? So they said, sir, they are also important. We were being told that it is only the GSM which is important because that is the way how the manufacturer has told us. Okay, sir, I'll give you you put in the tender as 200 GSM, I'll provide you a 300 GSM material. So therein I am trying to tell you, the quality audit people will be telling you, okay, these are not the only parameters which you have to look into. You have to look into some more parameters also. So quality auditing is usually carried out on periodic basis and includes a systematic examination of all systems and actions that influence the quality. The object being to ascertain compliance with the implementation of quality system, program, plan, specification or contract requirement. All these things have to be looked in by the quality audit. हम लोग को टी ब्रेक तो नहीं लेना है. Do we need a tea break? So we stop with the quality. We go in for the tea break. Okay. Recharge. Yes. हाँ. So do we stop the streaming for the tea break? उसको देख लीजिएगा या pause. If you have a pause then.